Hello, friends, and today I'm going to walk you through a demo of DataStax Enterprise solution, which is based on Apache Cassandra, which is integrated with analytics and search. So that is a very powerful capability that we provide. But today's demo is primarily focused on how do we provide a truly active configuration of your data across multiple data centers. And when I say across multiple data centers, it could be a near DC, which is within few miles or kilometers, or it could be far away with actual DR, right? So think about it. If you have a data center in Mumbai and another data center in Hyderabad, and how you would basically uh, create a truly active data center. The configuration that I have here is I have created an AWS instance where I have three data centers. One is Japan, second is Mumbai, and the third one is Singapore. Uh, I'm going to use these three data centers to showcase the capability of DAC. Um, Japan data center has 6 nodes, and similarly, Mumbai and Singapore data center has 6 nodes each, so total of 18 nodes cluster that we have. And what we're going to do is these clusters are configured in such a way that the data is replicated across three data centers. While we data is getting replicated on real time, which is a very native nature of Cassandra. It is not a third-party tool or anything that you need, but you just set up a data center and define which data you need to replicate, which table you need to replicate, which table you need to replicate on which data center. It's quite configurable, right? So we're going to start writing onto a Japan DC, bring down Japan DC nodes one by one and see how the impact is and how seamlessly the writing fails over to a Singapore DC. That's the demonstration that I'm going to do. While we are doing this, just to let you know that this node is heavily loaded with data. For example, if you run node tool table stats, which is node tool is a data stacks command that you run once you have implemented it. I'm running this on one of the node and I'm running it across demo.table1. Demo is in key space. Think about it as an instance. Within that instance, you have table1 as a table. We are going to actually write onto this table when we start writing, but I'm just trying to show you that table1 already has 500 million records, right? So it's a very heavily loaded data and database. Think about it. You cannot even query this at this moment. If you just run a query across the table, it's going to fail because it has 500 million. So the way to query this is by a primary key or a secondary key, which is a typical way of doing this. But in Cassandra, we use something called as partition key, and I'm going to talk about the partition key out here. Just to so let's start writing some data onto this particular table. I have a Python script which is going to start writing onto this table. And before we start writing, I just want to show you the structure of what this table looks like. So if I do a describe table demo dot table one, it will actually tell me that I'm basically writing on this table, which has bucket, timestamp, and some data into it. And my primary key is bucket and the timestamp, right? And if you look at the various configurations that we have, we'll come to those configurations later on. Let me start writing onto this data using this Python. So once I start writing, it will just connect to the clusters and it will actually start writing onto Japan DC. So if you look at it, it starts writing onto Japan DC. On the timestamp basis, it will create something called as a partition key, right? So if you start querying this data, in terms of what it is writing, I can just say select count star and I give a timestamp here, right? So the timestamp that I'm going to give here is obviously 1448, and it will tell me the count, right? So if I look at the 49 timestamp, it is still writing on to 49, and you will see the increase in the count 90, 94. So every minute it is basically creating a partition, and based on that, it is just dividing the data. So it's still writing on to 49, and you see the count increasing as I keep querying the data, right? And once the time changes, it will start creating a new bucket ID for that data. So still it's writing on 49. You see 214 records out there, which is written on this count, 229 records. I think the time has changed, and then now it must have started writing on 50, right? So the count now will start increasing on 50. The beauty of Cassandra is when you try to query a particular data, and if I have to query by bucket ID, then if I give a bucket ID, which is this number, it will go and fetch the data directly from this number, and it doesn't have to scan the uh, whole table space. And that's the power of Cassandra. The way it is writing the data, the read are very, very super efficient because it directly hits the bucket ID that you have provided here, right? Now that I have shown you what is happening on with this write.py, which is running, let me show you the capability of what happens when you try to shut down few of the nodes. So I'm going to move from this ring view to the list view. On the list view, you see the name of the hosts that are running and the data center that is running on. So I'm going to actually shut down few of them, and I'm going to actually shut down, which is an abrupt shutdown. I'll show you how. So if you drain before stopping, it is going to have a very good consistent shutdown. But without draining, it's an abrupt shutdown that is happening on 3 nodes. What I'm doing here is from 18 nodes, I'm bringing down few of the nodes on my cluster, and we'll see the impact, right? Because I have set the consistency level to 1, it will wait till at least it will keep writing till at least one node is available in the system, right? And what happens after even that one node goes down is something that we will see. Here's the one that you see that nodes going down, right? So 2 nodes has gone down. We'll wait for one more node to go down. And once that happens, we'll try to see if we can shut down few more nodes out here, right? Um, yep, so you have only 15 nodes here, and you see continuously there are writes still happening. Just to want to make sure that we prove ourselves the writes is still happening. I want to say here is a 52 number, and the writes are still happening, and the count is still going up. Now let's bring down further 2 more nodes out here, and let's do the same thing here. And I'm stopping the nodes. And in real life scenario, actually, you will be doing a consistency level of 3, so that at least 3 copies are available. And if 3 copies if less than 3 copies are available, it will try to fail over to other data center. But just for ease of purpose sake, I have just said that consistency level should be at 1, so that even if one node is available, it continues right? So here's the thing that while the nodes are shutting down, you see 5 nodes have gone down, and you still continue doing the writes on 53. And yep, that's it's still, you may feel the lag, obviously, because the throughput is coming down. Obviously, this needs to be configured based on the business requirements. As I said, uh, in your case, you may be saying, okay, if less than 3 nodes are available, then shift to the other data center. those kind of configurations, and I'll show you those where those configurations are being done, right? So 5 nodes are down. We have single node running in Japan, and you will see 1, 2, 3, 4, and 5 nodes are unresponsive. Only one node is active, and you continue seeing those writes still happening, right? Now let's see the magic what happens when even this node goes down, right? So I'm going to stop the last node in Japan that I have, and let's see what happens. While the writes is still happening on this, there could be some buffer which is happening, and yeah, there are some writes happening on this minute on Japan DC, and once the Japan DC is completely down, we should see some magic happening. We still see 5 nodes down. I want to see 6 nodes coming down. That's when Japan DC is completely going to go down. Right? Yeah, there's still writes happening on 55. Now there should be some writes on 55. Let's see if the node goes down and becomes unresponsive. That's what I want. I'm interested in. Let's run this one more time. To say stop. And you see here the data has automatically started writing onto sync DC. So the switchover is probably in fraction of seconds, where you won't see any downtime. The users are not at all impacted. So let's see the same table, and I'm just going to say still writing on 55, and the count are still increasing, right? So that's the power of Cassandra. You don't need to have additional tools to have this capability of an active data center. It's completely seamless for the end user, and that's the power of Cassandra that we bring on table. Apart from, obviously, we can do analytics, we can do search, and other capabilities that we have. And now that I have shown you how this failover is completely seamless, let me walk you through some of the settings uh, that that would be interesting of how we have done all these settings, right? So if I go to demo.ini, here is where I have defined all my nodes where it needs to get connected. This is my Cassandra cluster. And here is where I've defined that I need 3 copies in Japan, 3 copies in Singapore, and 3 copies in Mumbai. What I've also said is I need a consistency level of 1. That means even if I'm able to write on one node, it should give me the commit. And that is why the one node which was running in Japan, it was still writing, though I needed 3 copies. And this is something that you can change. CL equals to 1, 2, 3, or you can say quorum, so that it will wait, at least have a quorum of the nodes and to make sure it writes. So those kind of settings that we can change in the real life production environment, right? Now that I have explained you the overall capability in terms of how high availability and disaster recovery capabilities and an active data center capabilities are achieved with zero downtime capability, where you absolutely don't have any downtime. That's the capability I have demonstrated to you. What I want to also let you know is that these nodes are scalable. That means if you need more throughput, you can just keep adding nodes into this, and you will find that you have enough capacity to store data. Not only that, it will also improve your throughput. That means the overall IOs that you can do. Just to prove the capability of Cassandra, without any tuning or without any special configurations, I was able to achieve the throughput of, when I was pumping the data for when I was pumping the data 500 million records out onto these nodes. I just want to show you the amount of data that we are able to pump, right? So let me show you the number of write requests that I have processed in last day. And if you look at the peak that I have been able to achieve is almost 70,000 records per second, right? That's the power. If you look at it within probably 3 hours from 8 a.m. to 11 a.m., 11:30 a.m., I have almost reached a peak of 72,000 records per second without any special tuning, and we have confidence that we can move this from what you see on the screen into millions of records per second, right? So that's the capability that we have. 500 million records are stored, 3 hours of time, 72,000 records processed per second into the cluster, right? Uh, Now, the other thing that I want to show is the latency. Now, if I look at the overall latency, uh, it's never crossed. If you look at 99% of time, the latency has not crossed beyond 7.7 to 8 milliseconds, right? So again, it's very high throughput that you can get and very low latency that you can expect from this configuration. Mind you, I'm talking about only 18 nodes of configuration that I have done, which is running across multiple countries within APAC region, right? So think about the latencies that comes over the network, right? So it's very powerful in terms of the way it is replicating and the way it is able to achieve the required throughput and the latencies. Again, mind you, the amount of storage that it can store, 500 million records I have stored, 52 terabyte of total capacity that I have. I have almost free capacity of 52 terabyte, and you can scale this into petabytes, right? So think about it. If you want to bring the another 100 nodes into the cluster, there are customers globally where we can give you references where you can store hundreds of nodes. The other interesting stuff that I want to show you is while I was doing so much of writes, I wanted to show you the capability even after doing so much of writes, the amount of pending the amount of I'm sorry, I'm showing you the wrong graph, but the amount of write remote pending that are there while I was doing those writes is significantly low. Think about it. I am pumping around 70,000, 30, 40, 50,000 records per second. What this graph is showing you, how much records are pending on the remote side to be synced, right? So you see the numbers in probably less than 100, and sometimes it has peaked to around a few hundreds, right? So that's the fast IO throughput that it is running, and it is able to sync data center Singapore, data center Japan, and data center Mumbai. So very few syncs that are pending. This is a real-time data that you can see while the graph you're seeing today morning when I was pushing the data. You could clearly see the number of syncs that are pending in the site. Okay. The other thing that probably is would be of your interest is uh, the OS load, the CPU load, right? Across the cluster, while I was running, pumping so much of data, so much of data onto this cluster, the CPU utilization has maxed not more than 20%. So that's the kind of OS load that it, while I'm pumping so much of data, the maximum cluster that it has reached, average is less than 10% probably, right? So the cluster average is hardly 11% max, not even that. And maximum is it's reached around 20-21%. So you have enough disk capacity, enough uh, CPU capacity to pump more data. It clearly shows you with the graph that I'm showing you. That's the high level capability that I wanted to discuss here, and leave the demo here. If you have any further questions, please reach out to me or the team or the partners that we are working with. Thank you so much.